LISP ingress traffic engineering with priority and wait. In this video, I'm going to talk about the traffic engineering, ingress traffic engineering in LISP with two tools. The first is priority and the second is wait. You know that we configured priority and wait in the previous videos. Let me review the configuration of priority and wait, and after that we will talk about the priority. We will learn about the priority and also wait, and finally we can configure the priority and wait, and after that we can see the result of these tools. Okay, let me to review the configuration of the XTRs. You know that XTRs means ITR and also ETR. We are using these commands: router, LISP. Okay, and then router we will be in the router config router LISP. Okay, you know that we should configure these commands. The first command, for example, is IPv4 ITR, means this router is an ingress tunnel router, and also we should configure IPv4 ITR map resolver, and then the map resolver IP address ABCD. Okay, the next command is IPv4 ETR. The next command is IPv4 ETR map server. Okay, then the IP address of the map server, and after that we should use a key and then authentication key. And after that we should advertise the for example EID prefixes in this ETR. For example, the command is database mapping. Okay, we use this command database mapping, then EID, okay, slash, for example, length, and after that we should use the rlook address, and then we configure the priority with the value, and also wait with the value. In this video, I am going to talk about these two important tools of the LISP. These two value should be used for ingress traffic engineering. The first is priority. First, I'm going to talk about the priority. After learning the priority, we will talk about the wait. Okay, look at this scenario. For example, in this scenario we have XTR1 and XTR2. This means that the first LISP site, this is the first LISP site. For example, in the first LISP site we have two XTR. This is the first or LISP site 1, and also we have one other LISP site 2. This is the LISP site 2. In the LISP site 1 we are using two ETR or two XTR. R1 and R2 should advertise the EIDs in this network to the mapping server. Okay, let me to show you here. For example, R1 as XTR1 or ETR1, okay, should advertise the 192.168.10/24 with the rlook of, for example, quad 1 to the MS. This is the first message. And also another network, the another network is the 192.168, for example, 20 with the rlook of quad 1 to the MS. And also R2 ETR2 should advertise these two updates to the MS. ETR2 should advertise these two EIDs to the MS, quad 2, and also here rlook is quad 2. You know it. But after this advertisement, MS, okay, and learn, for example, for 192.168.10 to rlook. Now in the MS mapping table, in the MS EID to rlook table, we have two entry for the 192.168.10/24. The first received from the quad 1 and the second received from the quad 2, and also we have the same result for the 192.168.20/24, first received from the quad 1 RLOOK and then the quad 2. Okay, you know it. After that, assume that R3 ask from for example mapping resolver an entry for the 192.168.10. You know that, for example, VPC3 needs to send traffic to the VPC1, and because of that, VPC3 sends the traffic to R3 with the destination EID of 192.168.1, for example, 10. R3 asks the MR mapping resolver the RLOOK of the 192.168.10, and because MR should forward this request to the MS, now MS should send this request to the, for example, R1 and also R2, because both of them are advertising, okay, or both of them advertise the 192.168.10, and finally R3 should receive two messages and two RLOOK mapping. Now, after the advertisements in the R3, in the map cache table, okay, we have two entry. The first entry receive for the 192.168.10/24. The first entry received, for example, from quad 1, and the second entry received from the quad 2. The question is that R3 should forward the traffic to which of these two, for example, RLOOK. By default, R3 should use both of these paths to advertise the traffic to the 192.168.10, and also the same function should be happen to the 192.168.20. This is the first condition. This is the default condition. But in some cases, for example, we need to use the R1 as the highest priority router or highest priority, for example, ETR for the 192.168.10. For example, the goal is that R1 has the highest priority, okay, highest priority to reaching the 192.168.10, okay, or means the highest priority EID or ETR to reach to 192.168.10. How we can create this condition? How we can make R1 as the ingress the ingress of traffic destined to the 192.168.10/24 means the best ETR for these networks. Okay, how we can pull the traffic of R3 to R1 for these networks? It's so easy. Look at here. When ETR1, for example, R1 sending the 192.168.10 with the RLOOK of quad 1, it should advertise a priority value. You can set the priority. Priority is a number. The lower number means the highest priority. For example, I'm using the priority 1 in the advertisement of 192.168.10/24 for the RLOOK of quad 1, and also, for example, the priority of 2 for the route advertised, EID advertised by ETR2, means ETR1 now has the highest priority for these networks. Or maybe you need to make R2 as the highest priority for the 192.168.20. Okay, R2 is the highest priority router or highest priority ETR to receiving the traffic for the 192.168.20/24. It's so easy. You can advertise from the R1 the priority of 2 and the in the R2 the priority of 1. This means that the ATR2, the R2, has the highest priority for receiving the traffic of the, for example, 190 to 162.0. Don't forget, the lower priority is the better priority, is the highest priority. The lower means highest. Okay, let me first configure this scenario, and after that we can talk about again the detail of the priority and